So, in our notes today, this is Unit 2, Day 2, right? So you might want to write that on the top of your handout. Unit 2, Day 2 notes. All right, so they have given us a picture on number 1, and they have labeled the axis. On the x-axis, they have a unit of time in seconds, okay? Most of the time, what we're going to see today, the x-axis will be some form of time, whether it's minutes or hours or days or months or something like that, okay? So the majority of the time, you're going to have some form of time on your x-axis, all right? Now, the y-axis has what? The height, and since it tells me it's a roller coaster, it's going to be the height above the ground that the roller coaster is. Right? All right. So we can just like make up a story about this roller coaster. All right? That's all we're doing. I'm not going to write it down just to save time, because if y'all are copying a paragraph, it might take y'all 5 minutes. So we're just going to talk about it. Okay? Because y'all are smart and y'all can remember. Okay? So what happens to the roller coaster at the beginning? All right, so time always keeps going. Time never stops, does it? I wish I could freeze time sometimes, but time does not stop. All right? Time does not go backwards and time doesn't stop, right? Okay, so this roller coaster is going straight, right? It's not going up or down for a few seconds, and then what happens? It starts climbing, and it climbs a really steep hill, right? Right? Then it goes down a really steep hill, right? And then it goes up really quick. Then it goes up really quick, and then it goes down really straight. That's pretty vertical, isn't it? Okay, that's fun. But it's a short one, and then it goes straight across for a little bit, and then it goes up again, and then it goes straight back down again, and then that's the end of the ride. Right? Y'all see what I did? Okay, so we talked about the roller coaster, right? Right? So this was backwards. They gave us a graph, and we kind of interpreted what that graph meant and like made up a scenario about this roller coaster. Right? I've never seen that roller coaster. Right? It looked a little boring. I like to go upside down. All right. Okay. So now they're going to give us the scenario, and we have to come up with the graph. All right? So looky here. The graph is pretty blank, right? What quadrant would this be? Yeah, everything's positive, right? Because time is always going to be positive. We don't reverse time, right? Time goes to infinity positively all the time, right? Right? We didn't end 2019 and go back to 2018, did we? No, we keep going forward, all right? So time keeps going forward, and this is like basically an X and Y coordinate plane, except for it's only the first quadrant, all right? So all of our numbers are positive numbers. It says, in a single day, it snowed lightly during the morning and then heavily for the rest of the day. Graph the time on the x-axis and the total snowfall amount on the y-axis. Okay, let's talk about morning and stuff like that. So what would be a good unit of time, do you think? Maybe hours? Yeah, I would think maybe hours, because it's talking about the span of one day. Okay, so what do you think we should put on our y-axis? The amount of snowfall, probably, right? Yeah, probably in inches, especially in Tennessee. We don't get like feet. Yeah, right now we're getting 0 inches. Okay, so you want to always label your axis. And like I said, the majority of the time you're going to want to put time on your x-axis. All right. In a single day, it snowed lightly during the morning. Okay, lightly during the morning. That's the beginning of the day, right? Now, okay, here's the question. If it is snowing, the snowfall is going to continually go up, right? But it's snowing lightly, so this is just a little slow slant line, right? Y'all see that? Okay. Okay. Well, I'm just putting it into all these side conversations. All right. Then it says, then heavily for the rest of the day. So what happened to the snowfall then? it went up a lot steeper then, didn't it? So maybe it gradually goes up in the morning, and then at noontime it just shoots up like that. Y'all see that? You see what I'm saying? Now that might be dramatic, but it fits the scenario, right? Right, exactly. But y'all see how it is? You need to have like a low slant line here and then a more steeper line there. Does that make sense? Okay. See how hard this is? Not terrible. That one was pretty good. All right. Mia bought a painting. The value of the painting dropped by 25% after 1 year and then increased in value over the next 5 years, reaching a value that was twice of what she paid for it. Graph time on the x-axis. Okay. Tell me what to do. And the value of the painting on the y-axis. So the value is going to be a dollar amount, right? No. Because think about it. When she bought a painting, she paid money for it, didn't she?
Yeah, that's what I'm saying.
Yeah, so the painting had value when she bought it, right? The value was not $0. So let's say we start like right here. Y'all see that? Because we know eventually it's going to double, right? Y'all see that? So sometimes you got to look at the whole picture, okay? We know eventually it's going to double. So let's start Mia right here. And then it dropped 25%. 25% is another word for what? A fourth. So I'm going to go like a fourth of the way down. You see that? So that's like, I went a little too far. You think? Okay. So, I mean, we're estimating here for 1 year. Did it increase in value over the next 5 years? So this is 1 year, right? Then 2, 3, 4, 5 years, if you want to label it, to reaching a value that was twice what she paid for it. So when she's at 5 years, it needs to be double where this is. So it needs to be like up here. Do you see that? So it's steadily going to increase through 5 years. And it needs to be like looking similar to like double what it was when she paid for it. Does that make sense? Yeah, mine looks like a check mark. Does that make sense? Now, like I said, there might be some variation in yours and mine and somebody else's, but they need to look somewhat similar. Does that make sense? All right. I'm trying to find the answer key to make sure I'm not completely off track, but I don't think I am, but still. Okay. Here we go. Oh, yeah. Number 3. All right. A basketball was dropped out of a window onto the second floor of a school. From a second floor of the school to the concrete below. Each time the ball hit the ground, it bounced and reached the height that was half of the previous bounce. It continued doing this until it settled on the ground. Graph time on the x-axis. I like it when they tell me what to do. And the distance from the ground on the y-axis. Distance. Okay.
Do we have to put a unit with them every time?
No. Okay, so y'all know when you drop a basketball and you just drop it, it don't go straight to the floor and stick there, right? Unless it's one of those weighted basketballs, right? Right? Basketballs are made to bounce back up, right? And they don't, if you're just dropping it, it's not going to bounce all the way up from where you dropped it unless you put force with it, right? There's physics class for you today, right? Right? So if you just drop it, it's not going to come all the way down here unless you like purposely throw it, right? Okay. So when you drop a basketball and it said it come back up halfway every time, right? So if we drop it from a 2-story building, that's going to be the tallest it's ever going to get to. Y'all agree? So it's going to be like this and then come halfway, right? And then go like this and come halfway of that, right? Y'all see what I'm doing? And then this and come halfway of that. And then this. That's cool. And come right there. And then and forever, right? Something like that. But do y'all see how that? When it comes back up, it comes halfway. And obviously mine's not accurate because I didn't label everything, and I didn't use a ruler. But do y'all see how it's going? What do y'all think? Not terrible? All right, some of them are tricky. I ain't gonna lie, some of them get tricky. All right. Jace is speeding on a highway and gets stopped by the police officer. Sounds like Miss Isbell. And the officer gives him a ticket and continues on the highway. Graph time on the x-axis. Woohoo. And his speed on the y-axis.
Is it actually going to tell us what to put?
Well, it did this time. They won't always.
Is it going to be on the quiz?
No, it's going to be a matching. They will have 3 different scenarios and 3 different graphs, and you match what scenario matches what graph. It's easier than this. It's easier than this. Okay? So, Jace is speeding on the highway. So if he's speeding on the highway, he's starting out pretty fast, right? Okay. And he gets stopped by a police officer. What happens to his speed when he gets stopped?
It goes down.
All the way to the ground, right? His speed does. So he's speeding. He can, and we don't know if he's like got his cruise control on. So if that's the case, he's speeding level. He could be increasing in speed, right? He didn't say he was accelerating, right? So this could be going like this. Does that make sense? Or it could be level. And then it goes because he gets stopped, so he eventually comes to the stop. However you want to do it.
No, I'm not talking about dying. I'm talking about
Well, I'm sure he didn't just completely slam on his brakes because he might have been in traffic, right? But even if you do that, y'all, even if you do slam on your brakes, your car does not just stop automatically, right? Okay. So, okay, while he stopped, the police officers give him a ticket. Time still keeps going, right? So while it stopped, we still have a horizontal line here at the time, even though his speed is not doing anything. Does that make sense? And then it says, and then he continues on the highway. So then he will increase in speed, but hopefully he will not go as fast as he was before. Okay? Especially if that cop's still behind him. But do y'all see that? He's going at a high speed, and he goes all the way to 0 speed. Time keeps going, and he increases in speed again. Does that make sense? Okay. I think y'all can do this. I want y'all to try number 7. Yeah, we're skipping a few. Is that okay with y'all? Because I'm trusting that y'all understand this. That might be good. Yeah, we're skipping 6. Y'all do number 7 on your own. See if you can do it on your own. We're in pencil now, so if you mess up, that's what our racers are for. Give it a shot. School bus. I want to see. I want to see. Now keep in mind that the y-axis is her total distance. Not her distance between one stop to the next. It's the total distance.
I know it's crooked lines.
You're on the right track. Well, okay. When she cranks up the bus, how much distance has she traveled? 0. So you're going to start at the origin. Okay. So there you go. There's your start point.
I was starting. Yeah.
Just
Now I'm
I feel like I'm overthinking it.
You are.
So simple.
It is.
I'm overthinking it.
Now just think about it, y'all. Total distance. All right? Hang on. Y'all listen to me. Total distance. It's going to be continually doing what? Going up. Right? With some stops in between.
So it's not going to be going like this.
No, it's not going to be going back down because her distance is not going backwards to 0 if she's driving to school. Right? Right?
It's going to go. I don't know about that.
Yes, ma'am.
Just need to have more stops. Yeah. You good? You reached the top of your thing. Maybe she got to school already.
I've seen that.
I'm walking around. I'm seeing good looking grass. Good looking.
Question for you. When she has stopped, what does that look like? 'Cause she's not rolling down down the highway when a kid trying to get on. Hopefully, that's me.
So like,
Somebody get
she
killed.
go up. That's what my clothes go. That's when I try to do it.
So you need some horizontal. Yeah, we're not still rolling. It's like so her distance will stay the same while time is going, right? All right, so yeah, we said that distance is never going to go down, right? But it is going to make some level places when she's stopping, right? Right? So we should end up with something that looks like a staircase. But it's not going to be vertical. It's going to be, yeah. It's going to be angle, horizontal. Angle, horizontal. Angle, horizontal. Angle, horizontal. Angle. That's kind of vertical. Stupid, Miss Isabel. Angle, horizontal. Angle, horizontal. You see what I'm saying? Something looks like stairs, but they're angled. Does that make sense? Raise your hand if yours looks similar to mine. Y'all are so good. Skip down to number 9. Matching. Okay. We got 3 kids and 3 graphs. Yeah, kind of. Okay? But this is all about the same scenario. Theirs are all different scenarios. All right. So 3 kids. Is that Carney? Carrie. Oh my gosh, I can't read. Carrie. Yeah, it's better on y'all's paper than mine. Carrie, Luke, and Mason. All right. They get the same allowance each month from their parents. So I guess they're siblings. Carrie spent a small amount of her money in the first half of the month, then spent the rest in the second half of the month. Luke steadily spent his money throughout the entire month, and Mason rapidly spent all of his money the first half of the month. Match each child's spending with the correct graph below. Now, this is the dollars spent. Do you see that? So they're going to start spending $0. Does that make sense? Correct. So every one of them started in the origin, and that's correct. Does that make sense? They started, because it's not how much money they have, it's how much they spent. So you think about it that way. Got it? Not how much money they have, but how much they have spent. So that's going to be the reverse. So this one looks like they spent a lot at the beginning, and then they had nothing left to spend. Right? Who did that?
Mason.
Mason. I agree. This would be Mason. Okay. Now this one spent a little bit at the beginning, and then they spent a lot. Who did that? Carrie. See y'all. And Luke steadily spent his money throughout the month. Yeah, that would be Luke. Steady Luke. So is that okay with everybody? It's not terrible. Okay. So here we go. Oh, let me end my video. That's the end of notes for today. Unit 2, day 2. Have a good day.